Good morning, y'all. It's Miss Johnson. Welcome to today's video. All right, today we're going to be talking about factoring quadratics. In class this morning, I've got my lesson plan right here. We did some multiplication with the box method, and now we tried it. We tried it going backwards, right? And today we're going to formalize this going backwards product, this going backwards skill. It's called factoring, right? It's when we have an expression that just looks like, x squared plus x's plus a number. And then we're going to break it up into these two factors, two things multiplied together. And we're gonna think about it in much the same way as we did in class. But during the video, I'm going to connect it to the X puzzles we did for last night's homework, or a couple nights ago's homework. So let's recap on the X puzzles. When we have an X puzzle, we say, okay, the top number is 15, the bottom number is 8. These two numbers need to multiply to 15 and add to 8. And the two numbers that are going to fit there are 5 and 3. Let me make that a different color. 5 and 3. Because 3 times 5 is 15 and 3 plus 5 is 8. Seems good. We finished the X puzzle. Good on us. But if we go over here to factoring quadratics, if I have this quadratic and I say I want to factor it, what we've been doing in class, and I think one of the better methods for finding this is we plug these points strategically into a box where the x squared term is always in the upper left, the number term only, the constant term, is in the bottom right, and then the two x terms are on the other two spots. And now I want to find things that multiply to each box that goes right above and right to the left of that box. So for x squared, it's x times x. For 5x, we're going to have a 5 here and an x here. We've already got a 5. We've already got an x, so we know this top one needs to be a 5 in order to multiply to 5x. For 3x, we've already got an x. So right here, we need to have a 3. And then to check our work, does 3 times 5 equals 15? Yes, 3 times 5 does equal 15. This is a positive 5 and a positive 3. So we end up getting that this quadratic factors to x plus 3, x plus 5. Great, that's the process. We're going to do more examples of that. But for right now, what I want to do is I want to connect these two things. I want to connect the factoring quadratics and the X puzzles. You'll notice that if we had simplified this, the 5x and the 3x could have been added together. If we had simplified this, we would have gotten x squared plus 8x plus 15. And then one thing we can notice is the 8 from the bottom of the X puzzle was the middle term of our quadratic. And the 15 from the X puzzle was the last term of our quadratic. When we broke it up into 3 and 5 over here, that's how I, the teacher writing this example, broke this up into 3 into 5 right here. So the connection is whenever we're given just a quadratic that is in simplest form, that has all its like terms combined, and we want to be able to break up that middle term into useful parts, we do the X puzzle. We say, okay, the X puzzle for this simplified version of the quadratic is 15 on top, 8 on bottom. It's always the last term on top, the middle term on bottom. And that's how it is. When x squared has no number out front. We're going to break these up X puzzle style, and then we're going to rewrite this with the answers from the X puzzle being the diagonals on this box, or being the middle terms for here. I'm going to do some examples of that. And it turns out, let me do some examples for that. All right, if we have the red example, x squared plus 17x plus 30. If I make my X puzzle, I put the back number on top, and I put the middle number on bottom. I say, what multiplies to 30 and adds to 17? If I'm struggling, I come off to the side here and I say, okay, 30 can be 1 times 30, could be 2 times 15, could be 3 times 10, could be 5 times 6, and that's where we're at. And then I say, okay, 1 plus 30 is 31, 2 plus 15 is 17, perfect. This should be a 2, and this should be a 15. We multiply to 30, that's where we got this list. So every single thing here satisfies the top part of the X puzzle. And then we add to 17, so it has to be the second part, this 2 times 15. When I'm here, I've finished the X puzzle, there's no number out front of X squared, I can just write in these numbers as my factors. And that's a finished problem. So what we did is we broke up this polynomial, this quadratic, into two factors by saying what multiplies to 30 and adds to 17. And we said it's 15 and 2. Our answers must be 15 and 2. X plus 2 and X plus 15. Let's try again. For the green one, we're going to make our X puzzle where we say X squared minus 11X plus 30. The 30 should go on top. The 11 should go on bottom, but we're going to keep the sign. We're going to keep it minus 11. Okay. These are still the things that multiply to 30. But also, we could have had negatives in front of all these, because a negative 1 times a negative 30 is still 30. Right? A negative 2 times negative 15 is still 30. And now we add all these up. We know the first two don't work. Negative 3 plus negative 10 is negative 13. Not quite. Negative 5 plus negative 6 is negative 11. We're doing good. So here, we want this to be negative 5 and negative 6. And for our answer, we get minus 6, minus 5. We definitely could have put the minus 5 first and the minus 6 second. Doesn't really matter. One more example. If we have x squared minus 4x minus 12, we're again going to put our minus 12 and our minus 4 into our X puzzle. I'm going to say what multiplies to negative 12 and adds to negative 4. Over here, I'm going to write out all the stuff that multiplies to negative 12. Yeah, let me do it in this order. Oh, sorry, y'all. We've got negative 1 times 12, negative 2 times 6, negative 3 times 4. And then, of course, we could have had the opposite version as far as negatives go. And now we say, okay, which one of these adds to negative 4? Well, 2 and 6 add to positive 4 when the 2 is negative, but 2 and 6 add to negative 4 when the 6 is negative. So we go with the one that makes it negative 4. And now our answer becomes clear. Okay. One of the things we've noticed, or could notice, so sorry. One of the things we could notice here is that when both our numbers were pluses in the equation, both our numbers were pluses, right? Or we could say we had some pattern here where both of these were minuses. We had some pattern here, and it turns out both of these were different, right? So let's formalize that. Let's say in your original problem, where B is just a random number and C is a random number, there's kind of 4 ways where we could have pluses and minuses, right? They could both be pluses. They could have 1 plus and 1 minus where the plus is in the back. They could have 1 plus and 1 minus where the plus is in the front. And we'd have both minuses. Ignoring the number answers, right? Just putting in a placeholder, random M, random N. We can still already figure out what our signs will be over here. Let's do the first one first. If we're multiplying to a positive number and adding up to a positive number, that means both of our numbers were positive this whole time. But if we're multiplying to a positive number Still a number 2. But when we add up those numbers, we get a negative number. That means we must have done a negative both times. Let me explain that again. If we do a negative times a negative, it becomes positive. Amazing. If we do a negative number plus another negative number, it's always going to be negative. And that's what we're saying here. We're saying when we add them, they're negative. When we multiply them, they're positive. It must be that both of them are negative this whole time. So yeah, the kind of takeaway here is when we have a positive c, we always have the same signs. So the first one was both positive, the second one was both negative. When we have a negative c, that means we multiplied two numbers together, and the answer was a negative number. Right? The negative c is the answer for the multiplication, and when it's negative, that means one of these was negative and one of these was positive. So when the c is negative, it's different signs. And honestly, it doesn't really even matter if b is positive or negative. The middle term is positive or negative. When c is negative, you have 1 plus and 1 minus. And we can find a pattern about which one's the plus and which one's the minus, but we'll probably do that later. Okay, let me clean this up. So at this point in the video, I think you should be able to do the first section of the assignment. The first section of the assignment looks like this. Looks like the red, green, and blue example. The last section of the assignment is a challenge. We're going to do it because we like challenging math. And y'all are smart. Y'all can do it. The challenge comes in when this number is no longer 1. The challenge comes in is when we have like a 2x squared or a 5x squared or like a number x squared where the number isn't just 1, where it doesn't just go away. And the way we're going to do it, we're still going to do the Xbox method, right? We're still going to say, I want to find the two things I can put here that add up to 7 so that I can do my factoring like in class. And then read off the answers from the top and the left of the box to be my final factor answers. The way we do this is we start with an X puzzle, and we move to the box, move to the answer. It is called the Xbox method. Yay! Woo. All right. The Xbox method is the bottom number of your X puzzle is still just 7. Right? When you have a pattern that looks like this, so this is ax squared, this is plus bx, and this is plus c. Whenever I say a, I'm referring to this first number, this 2. Whenever I say b, I'm referring to 7. Whenever I say c, I'm referring to 6. So instead of saying the first, middle, and last numbers, I'm going to start saying a, b, and c when I'm talking about quadratics. And, in class, stop me if that's confusing. I will explain it again. Sorry, that was a tangent. But it's all to say, when you set up your Xbox method, the bottom number is b. The bottom number is your middle number from your question. The top number is your first times your last number, is a times c. So here, instead of plugging in 6, like we did at the top, we're going to plug in 12. We'll let that sink in. When we make our X puzzle for a quadratic that doesn't have, or that does have a number out front of x squared, the top of our X puzzle is a times c. It's the first number times the last number. Here it's 2 times 6. Now we're going to do our X puzzle. We're going to say what multiplies to 12 and adds up to 7. It is going to be 3 and 4. Right, 3 times 4 is 12, 3 plus 4 is 7. And then these numbers that we just filled in, those are what's going to go in our box. We're going to put 3x in one of them and 4x in the other. Nice. And now I am going to do the box thing, right? I'm going to say 2x squared is just 2x times x. 4x is 2x times positive 2. Positive 2 times positive 3 is 6. I'm going to check my work. X times positive 3 is 3x. I love it. And now we have our factors, our answer for this question. This is the challenge. There's 3 challenge problems in the assignment. Try your best. We will go over them either in office hours or in class. But that's that. All right, now good luck on the assignment. Let me know if you have help or need help or have questions. And I will see y'all on Monday. Bye.